Hello everyone and welcome to Rebel Way. My name is Andrew Sutherland and today we're going to be creating this lightning effect similar to the lightning or electricity that you see in Star Wars. And yeah, let's dive into Houdini and take a look at how it was done. So first things first is we can dive into this node here where we're just preparing our spacecrafts. And in this case, we've got this X-Wing. I'm just going to press F on my keyboard to frame up. And you can see we won't be able to share this model, but if you just Google Star Wars X-Wing OBJ, I'm sure you can find some free models. And I'm just transforming this up a bit. And press F on my keyboard. Hang on. Press F on my keyboard again. I'm just creating a VDB from polygons. Reshape it like this using a VDB reshape and then converting this back into polygons. So now we just have some like light geometry. So this is going to be so far away in the scene that, we don't really need any detail. I'm just saving this out as a proxy and putting a null to read in. Cool. So from there, we're going to dive in here, again, pressing F on my keyboard just to frame up. And first things first, you'll see, well, here we have a grid. Quite a bit of resolution on it, and then we're putting down this mountaintop to create some land, and then over here we're creating this bowl, and it's just simply a tube. I could have actually just put on end caps and then delete this. Actually, maybe that's a better way of doing it. And put down poly extrude. Whoa. So now we have this bowl here. And here we're going to prepare some geometry that we can instance onto our particles in the scene. So we start off with this tube and we sort of just scaling this down to create this like sort of spaceship sort of shape. Transforming this along this axis here. And then we're going to put a wrangle and we're going to create a particle ID. And this one's going to be set to 0. And it's the same thing for this one. This one's going to be set to 1. And this one's going to be set to 2. So just some different shapes with a different particle ID. So if we come over to our geometry spreadsheet, you can see we've got this particle ID. And that's going to become relevant in a moment. And again, pressing D on my keyboard. You can see we've got a few boxes here. And this is just a way of art directing our scene. So we've got these boxes. And from there, we're going to fill these up with some points. So we're using a points from volume, which is just basically going to make a volume out of our geometry and then fill it with some points. Here are our settings. Same for this one, and this one. And, having it separated like this just means that we can have some more artistic control over our scene. And from here, we're going to randomize the P scale. So this is just basically, currently this looks quite uniform as the scale because we're just looking at points. But when we copy some geometry to this, you can see we've got a variety of different sizes. And that size is being varied between 0.2 and 1. So if I were to disable this, you can see they're all uniform size. And now we have some variation. And we're doing that again for each one of these. Same thing. Next thing that we want to do is we want to give these objects some orientation variance. And we can do that by just by randomizing the normals. So if we were to undo this, you can see everything is facing the exact same way. And because this is being copied onto the points and oriented by the normal, just varying that normal means that we get some variation in the orientation. So, just like before, This is on all of our instances. So next up, we have this point VOP, and we're just taking the point number and we're randomizing it, and then we're fitting it between 0 and 3, and then we're exporting that as the particle ID. And this just means that we're now going to have, you know, it's going to, each one of these points is going to have a particle ID, and it's going to be randomized here. So if I were to disable this, you can see we don't have that particle ID, and now we do, and it's randomly being assigned to each one of these points. And then once we copy, it'll take this particle ID and assign it to the point. So if we were to, you know, undo this, as you can see, what it's actually doing is it's copying each one of those geometries onto every single point. And now with this, once we assign that particle ID, it's only going to assign its relevant, and now it's only going to assign the relevant object to that point. Again, we're doing that for each instance. Here we're just putting down some nulls for some, you know, labeling purposes, and we merge those together. And if we take a look, we can now see our debris and spaceships. Pretty cool. Next up, let's take a look at this lightning. So diving into this lightning, we can see we're importing our debris and ships, and we're going to put down an assemble node and tick on create packed primitives. And this create packed primitives is also going to give us a name attribute, but it's also going to, basically what it does is it's packing each one of these objects and it's assigning it just to that point. And so what we can do then is delete all geometry but keep points, and now we'll have the centroid of all of these, of all our debris and ships, and that's what we've got here. So now we're just deleting some of these points. You can see we're deleting a few points, and we're creating a randomized color on these points. So just an attribute randomize, and we using CD. And then what we're doing here is we're putting down a numerator and we're creating a particle ID for each one of these. So if we come over to our geometry spreadsheet, we can see we now have an ID. So before, no ID, and now we have an ID. Great, so each one of these has an individual number. Diving into the VOP, we can see we're taking the color and the position. So this is going to create a noise, and you know, so some colors will be here, some will be there, you know, and where the colors are grouped are going to be based on that noise. So let me enable that first of all, so we can see. And you can see on our ramp, we've got this blue, red, and green. And that is just, you know, the position of our noise basically. And we're feeding the position of that noise into color. If we were to play with this frequency size, obviously we would change where the color is located. But those are our settings. And what that then allows us to do is to separate this based on the color. So this blast is going to be deleting everything but the red, everything but the green, and everything but the blue. You know, we're just saying here, you know, color CD at R, so the red channel, anything with a value above 0.1, anything with a value above 0.4, delete. So yeah, if we wanted the opposite, just change this. And now we have the blue and the green. And this R, G, and B is obviously for red, green, and blue. You could actually also just say, you know, X, Y, and Z, and Houdini will understand the exact same thing. Cool, because it's a vector, X, Y, and Z components, or R, G, and B. From there, we can create a group, and we can group this as red, we can group this as green, and we can group this as blue. And in this case, I felt that these points were just a little bit lower and, you know, were a bit too close to the center of the scene. So I just made another group where I just selected some of these points, called them group 2, and I transformed them out here. And the same goes for these points. I just transformed them a bit again. This is just, I was basically just art directing, just making a few tweaks. And on here, on the green, we're using a group range to select some points randomly, and then we're just deleting them. You could do the same thing with the wrangle. I do this all the time, you know, attribute wrangle. I use this so often, I've got this saved as a preset, so I can just come down here and say remove points with slider. Let me press D on my keyboard, make this black, and I've got my point size turned up to the maximum. But you can see here I'm reducing the number of points with this slider. And that's basically the same thing that we're doing here. We're just reducing the points. Yeah, so this is exactly a very similar thing to what we're doing here. We're just doing a group range, calling it reduce, and we're filtering. And then deleting the points in the reduce group. Cool. So we merge those all together, and now we have our points. And we have some very simple SOP solver here, and it's really not doing much other than just moving our points based on this noise. So we're taking the position, adding a noise, we're adding that back to the position, adding that to, yeah, and we're exporting that as position. And here we have some, you can see we're moving it along the X, not the Y and the Z. So the X and the Z is being affected. And if we were to then enable this, we'll see our points. Let's click this on to see this in real time. And we just got a little bit of movement on our points. From here, we're just going to delete those colors. So this attribute is just removing that color. Again, we're randomizing the P scale between 0.4 and 1. And here we've got our X-wing that that proxy that we created, just using this transform, and we're going to copy those to those points. And we're going to put down a null. Cool, so onto the actual lightning part now. As first things first, we're going to put down this line. We're going to create a poly wire. And we're going to isolate just this top section. And then what we're going to do is we're going to array all these points onto this line here. And because these points all have an ID, what we can then do is merge them together and put down an add node and connect them based on that ID attribute. And that's just going to create a line between the point, because the point out here with a ID is also going to be the point here with the same ID. And if we were to then connect those, we get these lines here. Next thing up, we're just going to put down a resample. So if I were to enable my points, you can see we've got that beginning point and end point, but we can resample that, and we tick on this curve view attribute. And this curve view attribute is very important and very useful in Houdini. And what it's going to do is basically just map a value from 0 to 1 along this line. And we can put down a color node, and we can just inspect that quick. So if we tick on here and we say ramp by attribute, and why am I not getting a ramp? There we go. And just type in curve view. Cool. I don't know why this is bugging. Let me just stop. There we go. So we can make this red and blue. So anything with a value of 0 is going to be red, and everything with a value of 1 is going to be blue. So you can see we've now got this really cool attribute traveling along this line, and we can use this for all sorts of things in Houdini. So we're going to promote our groups from points to primitives. As you can see, we've got these groups here and they're points, and we're going to put down this group, and now we can see we've got these groups as primitives. And then like we did before, we can just blast based on the color. So now we've got our red, our green, and our blue. And now we've got this loop here. And what we're going to do in this loop is we're just going to use a carve node to animate this line so it grows like this. So what we're doing, we're resampling again. As you can see, that's how many points we got. We need more points. So resampling there. Again, we've got this curve view attribute. And essentially, this is being animated from 0 to 1. You could just do this manually, like, animate this 0 to 1 from here to here. In this case, we're using some expressions to do that. Basically, all it is being animated from 0 to 1. And we're doing the same for the red, green, and blue, just at different times. So the red goes on, then the green, and if I remember correctly, the blue was almost very similar to the green timing wise. So let's turn this off. So you can see the red, the green, and the blue. Cool. And these loops are pretty cool. So basically what it's doing is it's allowing us to run this procedure over each one of these lines individually. And then once we put this block at the end, it's going to run it on each one. So if we come here, you can see we've just got the one, and then it's going to run it over each one of these pieces. Pretty cool. Merge that together. And from here, we're going to create some attributes. And we're reading in that curve view attribute, and we're going to be using that to generate these two attributes, opacity and emission, and also a color. So if we take a look here, we're taking the ID and we're randomizing that, and we're also adding an offset. We're multiplying those and creating this curve view, and then it's going into this ramp. And so let's just take a look at this attribute quickly. Put down a color. And we say ramp from attributes, and we can say emission. And you can see we've got this sort of pulsing, or variation on our ramp here. So here's our ramp. And because this is being saved out, the color, the opacity, and the emission, these should all be the same. So emission, color, and opacity. Yeah, they're all exactly the same. And so here what we're doing, we're creating an attribute called alpha, which is going to give us some transparency. And we're saying that is the same as the color. So these parts are going to be solid and these dark parts are going to be more transparent. And we're going to put the exact same thing on our line here. So same thing, we're also creating a carve, animating that up from there to there, resampling it, creating a curve view, creating a group, exactly like we had over there. Here we can see we're creating this breakup on our line in terms of color here. And then we're going to merge this together. Cool. We're also fusing these together. So our lines are all connected. Again, resampling. So before, after, this two-way split. So we've got this group called first switch. So that's going to come out here. And our lines are going to come out here. And here we can create some noise on our lightning. So basically we're just taking the position and we're adding that to this turbulent noise. It's alligator noise, this is our frequency. We're taking our point number and we're fitting that into the amplitude. And that's going out to our position. We're taking that curve view, we've got a fit. It's not actually doing anything. It's, mapping 0 to 1 to 0 to 1, so it's not doing anything. And that is going into this ramp. And you can see the ramp is being mapped here. So you can't really set your ramps inside of the VOP. You have to dive outside, and we set that out here. So you can see that there. And basically we're creating some noise. So basically we're just going to be noising up the position of this as well as adding some breakup on the color. And then we're going to do that again. This time literally just noise, the second layer of noise for the position. And the same goes for these lines. So as you can see, put down a null here. So if we take a look at those lines, and you can see we're noising that up. And we've got a bunch of controls promoted from inside the VOP here to the outside. And you see the main one is this color. So we've got a ramp for our color. And that is coming from here, taking our curve view, putting into a fit into this ramp. I don't think this fit is doing anything, but sometimes a fit can work like a normalization, just making sure our values are between 0 and 1. In this case, not really necessary. Might as well delete it. But yeah, this is this ramp, and we can just set a color along the curve view, so you can see starting off white, then going blue, then white, and some variation there. And we have this amplitude. And here too, right? and then this large overall amplitude. Frequency noise. And you can just tweak these based on your reference. And then this roughness. So if we bring this down, this will look more like a plasma ball. So something closer scale. And, you know, that's obviously too much. But I would say that's a good value for a large scale electricity bolt. Something like that. And then we're also creating a noise curve here. So this is not being affected, and then in the middle part is being affected, and then isn't being affected. So if you bring this down, you'll see our noise is going to reduce and not. And if we were to turn this up, we'll see the ends, or in this case, the beginning part is being affected. Whoops, and the end part. But because we don't want to distort the end part or the beginning part too much, we can use this ramp. Cool. And so these are just parameters that are exposed and labeled so that we can control these out here. But all it is basically the frequency, the offset, the amplitude, and the roughness. And on this case, we've got that curve view going into this ramp here, and that is this ramp here. So, and we're just using that as a multiplier. And that should go into our amplitude. Yep. Cool. So that's that for the VOP. It's pretty simple. Let's disable this. And this is just a little bit of extra noise here. Very subtle. Again, the curve view, some offset. We're just taking the color, randomizing. So just a little bit of variation here. So yeah, just again, same thing. It's really just this turbulent noise. And we're adding that to the current position and out. And these are just some extra controls. On this node here, we're creating a p-scale and we're giving it a value of 0.002. We're going to call this branches, just a null for organization purposes. And then we're going to use the color to determine the thickness. So if we take the color, we put it into this ramp. Again, we've got this fit, and you can see these values have been promoted up here. So if we come here, what were they? Source max, destination min, and destination max. So that is here, destination min and destination max. And we're saving this as p-scale. So our lowest value for the particle scale is going to be 0.1, and the maximum is going to be 0.5. And yeah, we're just using the one value and saving because we're reading in a color, which is a vector, and we only need a float. So we're just taking the first value here, and we're saving this out as p-scale. So we now have this p-scale. The same thing for this one. Here we're just restoring the color. We're merging those all together. We're doing some more color. Again, we're redoing the color here. So we're just reading in the curve view, a ramp, and out to color. So just like we've done before, using this ramp to set our colors. And in this case, we're putting a material down. And that's it for our lightning. Cool. So next up, let's take a look at this fog. So we jump into this fog node. If we come up to the top, we can see we've got this object merge and we're reading in our lightning. And from here, we're setting the alpha from 0 to, we've got this mapping here. And we're moving this over to give us some more breakups like that. And from here, we're creating a density of the color. So if I enable this, you can just see we have a density attribute. And if we come over to this rasterize attributes, so here we're creating a density from those points, and here we're going to convert that SDF into a fog. And we're actually going to label this as temperature, and we're going to multiply it with a density. So in order to create this overall density, we're going to put down a box, and this is going to become our domain. And we're creating a density from this box. And then we're going to create a noise here. And so we're reading in the bounds. We're reading in this relative box, B box. And we've got this ramp here. And this ramp is going to be this. And so you can see here we've got these three lines. Like this big section here. And then it goes very dark that we see here. Goes a little bit lighter. And then light again. And then very dark. And so if we were to if we wanted a line along here, we could just put some black here, and you can see we've now created that dark part. And as we move this around, you can see that's what that's giving us, and that is coming from this ramp here, and that's just going out into the density, and then we're just multiplying it with a noise here. So this noise is going to give us this breakup. Here we're just making sure that we do actually have a fog and not just a sign distance field. And we've got this cloud noise, and that's going to give us even more sort of noisy breakups. It's very similar to that noise that we had inside the VOP. So on this node, we're multiplying the density by this. So we're only going to have, because we're going to rename this one to temperature, but we want to mask it by our cloud. So if we do this multiplication here, you can see we now only have this part where we also have clouds, and we're just going to rename that to temperature. So this is just like a rename node basically, and you can experiment with merging this in with the original. What I mean by that is, I'll come out here. You can see the difference. You can see that this is sort of masked here, and actually, tell you the truth, I didn't actually use this temperature part. I'm going to show you how in Arnold to control a mesh light and use the fall off. But if you want to experiment with this, basically we were creating a temperature field. That's what we're doing here. And we're just using some multiplication over here to multiply this temperature part with the density. And that just ensures that our temperature only shows up inside the volume, inside the sort of clouds. So yeah, it's renamed to temperature. We're not using these. We're making sure that this is now called density. Let's check density. Again, some more cloud noise to break this up. And now we're calling it temperature again. Let me just check something. Temperature. Oh, yeah, we need to call this density so that this cloud noise will work. So if we were to disable this, yeah, we're not going to get what we want. So we're just going to call this density temperature temporarily so that we can use this cloud noise, and then we're going to convert it back to temperature again. Same thing over here. We're also creating some cloud noise, noising this up, and then we're just going to merge this out, and then we're going to save it. And we can put down a volume visualization to see what we've got here. I was also trying out merging this in. And it's going to isolate this a bit more because we have more density there. But it's up to you. And like I said, I actually ended up doing this all in a mesh light with Arnold. Cool. So that's it for the volume. It's quite simple. And let's take a look next at rendering and putting together our scene. Okay, so I've got these geometries here where I'm reading in all the aspects from our simulation or our lightning setup. And, so the fog is being read in with this object merge. So this is collecting our smoke that we've just created. And obviously this needs to be scaled up. So I've got this transform here where we're scaling it up to scene. And what I wanted to do is I wanted to add some volume to even where we don't have any volume. So if we take a look here and I come to, so there's not much density in these sections here, and I wanted to fill that in a bit and and have the scene just denser where there is cloud. So I'm just going to hide everything else. And so in order to do that, I put down a bound, which is going to encompass our scene. And then I just created a VDB from polygons, and that's going to fill this box up with a uniform fog. And then I just set a value of 0.08 here. So it's a very light volume. And then I just merged it in with our original, but I also added some more cloud noise. So as you can see, we have this before, and then I really sort of broke this up more to get more detail, and again I lowered the density of this. And then once I merged those together, you can see we're filling in those empty gaps with just a little bit of density. Then yeah, obviously if you're transforming that up back to scene, so if I come to camera 2 and I save that out to disk and put down a material node. So we'll come back and take a look at these materials, but they're very simple. And so yeah, that was the fog. Here I'm reading in the debris, I'm reading in our X-wings. Again, we're going to put down a transform to transform those up to scene. Merging those together, and then I'm really just deleting attributes. So I'm deleting everything I don't need, putting down a group. As you can see, if we come up here, we don't need all this information. So I'm just deleting groups, and now we've just got everything we need, and recomputing the normals, saving that out to disk and putting down a material. Now the lightning, reading in the lightning. We again come here, let me just press D on my keyboard, change this back to black. And here we're setting a particle scale, so like the thickness, and then we're putting down a polywire. Again, controlling thickness. Those are settings, computing the normals again, and just like before, cleaning up some attributes. So we can delete our groups here. We don't need these, so that's going to delete that. And we put down a color, which I'm then deleting, so no need for this. Transforming this up to scene, and then saving that out to disk. And this is saved as a mesh because we're going to read this in on our mesh light. So if we come over here, you can see we're reading in this node. So if I drag this over to there, and I'll come back to the lights once we've taken a look at all these geometries. So we'll come back to this. And on here, this is I've just got a very simple shader on this one. So we're reading in again, setting the P scale, same as before, putting it down a polywire, not computing the normals, transforming it up, and saving it to disk. And then here, I actually just scattered points on the geometry. I don't think this is actually necessary, but I was just experimenting with the renders with the amount of points I put on, and I just liked the way it looked, so I kept it. So just put some points on there and then put down a shader for that. For our environment, we've got importing our scene, transforming this up, and then I'm just grouping all these debris parts and just blasting them out the way, and then saving that to disk and putting down a material. Cool. So that's all our geometry prep for rendering. And like I said, if you come over to stage here, so if you don't have Arnold, we do have a setup in stage here using Karma for rendering. So check out our Karma tutorials. All this stuff has been covered in previous tutorials. And yeah, this is a very, very simple setup. We're basically just importing the lightning, importing, you know, all the things that we need, some simple lights, and just doing a render. But you know, go and check out our rendering tutorials, and I'm sure that this will all make sense. It's very, very simple. Okay, so we're going to talk about the lighting, shading, and rendering in Arnold part now. And it's important to note that while I'm doing these renders, I have Nuke open up here, and I'll render things out and I'll start compositing. And usually, you know, I do my best to just work on a frame. So, you know, render out one fog frame, render out the lightning. And then what I'll do is I'll put those renders into Nuke, work on the composite, and try and match my reference as much as possible. And that way I know that, you know, if there's something else I need from Houdini, I go back to Houdini and I render out more AOVs, make changes to my shading, so on and so forth. And that's just the way I like to work. So jumping back to Houdini, let's take a look at what we've done with the lights. And I've got these 4 lights here. I've got this mesh light, and this mesh light is reading in our geometry from the lightning. So I just take this and drag it in here. And what I've added to this light is actually a light shader. So if you click on this button here, you can dive into this shader network for your light. And I've done a quick render here. Without this light decay, I have something more like this. So this is the result of just this. And you can see we're getting this nice halo around our lightning. But based on my reference, I wanted to sort of decay this light. I didn't want it to travel out as far here. And I didn't want to have this line around the geometry so much. So I added this light decay. And these are our settings, and with that added, I now get something more like this. And the other thing to note is on the output, if I come over to this light, we're forcing the fog, and we're excluding the simple shader version, which is just the plain color lightning. I'll show that in a bit. And I've got this the actual mesh light as phantom. So what that means is that we're not seeing the geometry in the render, but we're getting all the illumination from it. And then of course under force matte we've got the environment and our airships. So that's just going to punch these holes in here. And I'm forcing all the Arnold lights, and I'm excluding these 2 point lights, which were just for, you know, I was experimenting with these, didn't end up using them. So I've put that into exclude those lights. As for the shader on the fog, we come over here and we just take a look. All it is a standard surface, density, and that's just going out to volume. And you might want to tweak this this density sometimes, but instead of tweaking it here, I actually set up the values like I showed before on these wrangles. So here and here. Same control really. We just, you know, You could do it in the shader, you could do it, but instead, because I'm layering these two densities together, I just wanted to control it here rather. Cool, so that's that for the fog. This blue light, we have this point light, and it's just a light in the center that's going to give us this illumination we see here. And if I take a look at our AOVs, we can actually see that. So this is just the point light. This is our mesh light. This is our environment, which is just an overall purple tint. It's an HDRI, but it's just tinted a bit purple, and I'll show you that in a second. And this quad light, so just a quad just pointing up. And that's really it for the AOVs. Let's take a look at this quad light settings and the environment light. And again, I have a shader on here. And the reason for doing that here is that I can now multiply it with this purple color and tint it. So you got to make sure that you have this HDRI loaded in here. And in fact, I'm probably just going to delete this when I share the project, because if you don't have this loaded, it's not going to render. So I'll probably end up just deleting this. But what I suggest you do is put down an image node, load in this HDRI. It's from HDRI Haven, and you can have this multiply here. So I could just go texture. So this will just be that HDRI, but this time it's no longer multiplied by that purple color. Cool. The other thing that I did on all these lights is I wanted to separate out these AOVs so we can have some more control in Nuke. And in order to do that, I've come over to contribution, and under this AOV light group, I just write, write a name, anything. In this case, this quad light. This one's going to be ENV, and this one's going to be point, and this one's going to be mesh. And in order to get these to show up in our render, we need to put RGBA underscore and then that name. So if we come over to the output, and I come over to this fog, and we go up to our AOVs, I've got a bunch of AOVs. And like you can see here, the RGB and then that name. RGB and then that name. And just do that for all your lights. Here I'm doing the Z pass. So that looks like this. And if I just gamma this down, you can see now we have this depth pass. I didn't end up using it, but always useful to have. And that's it for those AOVs. Just render that out. These are my overall settings. This does take quite a while to render. These large volume fogs always take their time to render, but using a mesh light is going to give us this illumination that we get here, and this is probably, I think this is the best way to do it. So that's it for our volume fog. Our environment, really simple. Just reading that in, excluding all these things. It's just got a basic shader on here. Nothing fancy at all. That's really it. Again, AOVs, mesh, point, separating out the lights. And like I said, I didn't actually end up using this. And the last one is actually a mantra render. And you can see that here. And all it is these simple lines. And now this section, I was definitely jumping between Nuke and Houdini a lot and making sure that I had what I needed from this render. And what I ended up actually just using, I think I just used the color and I used the alpha. So if I jump over to this shader now, so under this one, I go shaders, simple lighting. This is just a mantra one, and I'm just reading in the curve view. I'm using this power node, which is, I often think of it as kind of like a contrast. It adds some contrast. and multiplying that down, but then multiplying this up all by 5. So this is just giving some control to the curve view, manipulating the curve view, and then multiplying it up with this, and that's just going out. And then I'm using this here to prepare some AOV. So the alpha is being read in and being exported as an AOV. The color is being read in and exported as an AOV, the curve view, and the emission. And I think probably in comp, I can go and have a look. If I come over to my lightning, I'm reading in the alpha, and I think that's actually all I used. Just used the alpha. But yeah, you know, if you've taken Hunter's advanced magic effects, you can, you know, he shows a bunch of techniques to prepare all kinds of different information along the lightning, so you could get more control. And if I had more time on this, I would probably experiment with that a bit more. I think I could, you know, match the reference exactly if I were to add some more AOVs to this shader and have more control in the compositing side. So jumping back to Houdini, and we go to mantra, and you can see I'm preparing these, just the curve view, CD, and the alpha. And like I said, I only actually ended up using the alpha. Under my settings, and this renders pretty quickly. You know, it's very, very simple. That's it for this lightning render. So we're going to briefly take a look at the composite here. And like I said, it's quite important for lightning effects, the compositing side. And what it really is I'm layering up some glows, and then, you know, doing some color correction and some vignettes to the overall scene. So over here, I have our volume fog, and maybe first I should press S and say that I'm working in Ace's color space. So if we take a look at the volume fog, I'm shuffling out these AOVs. So here is my environment, and it's just this like sort of purple color, and I'm color correcting it to give it more blue, and it's actually almost completely black, really. Let me see if I'm actually automating this gain here. So in some places it's going to be brighter, and some places are going to be darker. And I was just doing this automation along with my reference. So I loaded the original Star Wars scene up here, and I was doing this animation to match the references as close as possible. So if you using this for your own lightning effects, try and, you know, load up a reference and try and match that as close as possible. So that's the environment, and then we have this impact light, and again just color correcting it, you know, moving down the greens and the reds and lowering this. So I'll do my color correction here, and then I do my animation on this one, same thing, you know, just animating the gain here. Then the mesh light, jump to a frame where it sort of spreads out. So shuffling that out, and the way I'm shuffling it out, you know, you just come over to here and you feed that into the RGBA. Same for all of these. So this one is obviously the quad light, this one's the environment, and then some color correction, and then the animation on this one, same as before. And then I added some glow to this, and this is I think this might be a gizmo, this exponential glow. I think it's from Nukipedia. So I could be wrong, but I think this is from Nukepedia. I got this from taking the Nick's Nuke course. And, you know, he shares a bunch of resources and cool gizmos. So you could just use the standard nuke glow, but I'm using this exponential glow. And here we have the bottom. So we're shuffling this out, and this is our point light illuminating the scene. And again, just color correcting this and really just trying to silhouette this geometry at the bottom here. And then we plus these all together. So that's the impact on the environment, you know, adding all our lights together. And so that's our volume fog. Next thing what we're doing is we merging in the geometry, and I was experimenting here, and basically, you know, I shuffled out the environment light and this point light. Then I did some color correction, but at the end I just decided that I actually just wanted these to be dark. So these are completely black, so it looks kind of just like this. And if I were to re-render a few things, I might want to create some sort of rim light on these objects and just use that light. That's what I see in the Star Wars reference, but you know, this looks cool too, just silhouetted with the volume fog. Next is my lightning, and I'm shuffling out the alpha, and I just ended up using the alpha. We also have the color, but I ended up just using this and rather tinting it. So what the reason I've got this format over here is because when I render out very thin lines or particles, and if I can get away with it, if it's a quick render like this one was, I sometimes render out 2 times the size and then scale it back down. It just, you know, makes sure that my lines are very, very sharp and I'm not losing any detail. So that's why I have that reformat. So this reformat is just resizing it back down to my project setting, which is 1920 by 817. And here I'm isolating just these very white parts. So we take a look here, and then color correcting, just reducing it really down to some very little points, clamping those values, then color correcting again, and putting it into exponential glow. So I think it's important to note that while I'm working on this comp, I very roughly put things together, and I actually look at it out here. And then I come back and I start layering things up and controlling the gain here. So it might not make a whole lot of sense as to what I'm doing if I go through this node by node like this. But actually when I come back out here, you can see that these color corrections are doing, this clamp's not really doing anything, but neither is this. But I was sort of adding these things and making tweaks along the way. So let's just, with that in mind, let's just take a look at what settings I've got here. So I've got that, I'm clamping it, which like I stated isn't really doing much. You know, someone like Nick, I think, you know, is very surgical with his compositing, but I'm just trying to match my reference as close as possible. So sometimes I put down things or color corrections that aren't really doing too much, and you know, as long as at the end of my comp it looks close enough, I'm happy with it. But there might be a few nodes here that aren't doing a whole lot. And if we come take a look at this one, you can see, yeah, again, yeah, no, this one is doing quite a lot, and that's because, let's just take a look at it here, I'm just layering these all together, and then when they come out here we have something like this. And yeah, it's all very, like, you know, small little tweaks on the gain mainly. And then here I'm grading these all together, adding another glow, and then I'm multiplying it with my background. So I've got this background, I'm adding a vignette here, so just a little bit of darkening around here. So this remains the same, and this is going to be darkened just a touch. I've obviously got a blur to blur out that mask. And then I'm multiplying this background with my lightning. So we now have this, and this is where I'm getting the color from. It's sort of inheriting the color from the background. Then I'm color correcting it here again to give it a little bit of more green here, so you can see maybe it's a bit too much, but I did notice a little bit of green in my reference. And then merging this over again. So from here we have that, multiplying this, and then multiplying it on top. Then over here we have another color correct. Not doing a whole lot, admittedly. I think I'm just turning the saturation up a little bit. You know, I would experiment with something like this, and if I ended up it not being necessary, you know, just small, tiny tweaks. And sometimes these tiny tweaks add up and make a difference, sometimes not. And here I'm creating some flares. And so if I take a look, when we have this impact point, let me come back out here. Yeah, you can see I have this halo effect, and that is coming from this flare node. And these flares I've disabled, and I think what I'm going to do for the final is I might you know, make some flares in Photoshop, or find some flares online and just create a big glow here and some anamorphic sort of lines. So in my final composite, I'll probably just add that in, and I'll literally just find like an image and layer those over. You know, this one was trying to get something, and you can come to these presets and try different things here. You come over to, yeah, you can create your own flares here. But I was finding that this was quite finicky, and for me, I'm personally just going to like Photoshop something together and just layer it on top. So probably not going to use this one, but I really like this halo effect here. So I'm going to keep that one and then add whatever else I need in Photoshop, and then just merge it in over here. So I'm plussing that together. I'm adding some motion blur. And here another gizmo, but this is just some chromatic aberration. And if we just take a look here, it's very subtle, but I'm adding a little bit of red and green here, and then again another layer of chromatic aberration. Let's see if we can find maybe a later frame with some more. So over here you can see this sort of red and green separation. So if I turn this off, this is very subtle. This one might be a bit more extreme. Yeah, you can see that we've got some green here and some red. And that's coming from this chromatic aberration gizmo. And of course over here I'm actually masking this out by the luminance. So I've got this key here. If we come over to alpha, we can see this is my key. Then we're dilating that, blurring it, and then that is being used as a mask for this chromatic aberration. So this is an overall chromatic aberration. This one, very subtle. And then this one is just affecting the brightest areas. From here, I've got some lens distortion. And, you know, I was analyzing a plate that I got from Nick. And I think the new courses, you know, are very important actually for effects artists. It's personally helped me a lot with my work. So I highly recommend checking out Nick's new course. And Nick will show these sort of things far more in depth. But basically, I'm just distorting the edges here with this lens distortion. And then I'm adding some more vignette. Just getting these things down, using this as a mask, blurring that mask, another vignette, and this is also being automated. Again, I was just matching these values to my reference. Then another gizmo, this is the DAS grain. And as you can see here, I'm adding in some grain from real footage. Again, Nick covers this in the course, and I am using a paid for grain. This is from the I think this website's called Holy Grain, and I've got the 16mm and 35mm. I think I'm using this one. No, I'm actually using the 16mm grain. And yeah, this is now being added some film grain to the darker parts. So there's more grain in the dark parts and not so much grain in the lighter parts. And here this is my reference, and then I'm writing it out to disk. So that's that for our composite, and pretty happy with this. I think I might just, for the final intro, I might just, like I said, add in those lens flares, and that'll be about it. So thanks for watching. I hope you guys learned something. And I'd also like to give a very big shout out to Toufik Mekbel, who was the artist that created this lightning setup. I just, did some renders, I made a few tweaks, and did the composite. So a lot of the heavy lifting with this lightning effect and the initial setup was all him. And he's done an amazing job, so thank you so much. And I hope you guys enjoyed this. I hope you got something out of this. I'd love to see what you guys come up with using these techniques, and I will see you next time. Thanks, bye.